So the first item for today is the annual performance report, CNL, formerly AECL, get used to this nomenclature, Nuclear Sites and Project 2013 is outlined under CMD 14M79 and 14M79.A. I understand that first we have CNL staff here and people who can help in explaining the annual performance. But first, I understand we're going to hear from CNSC and Mr. Newland. The floor is yours.
Thank you. Good morning, Mr. President, members of the Commission. My name is David Newland, and I am the Acting Director General of the Directorate of Nuclear Cycle and Facilities Regulation. With me today are Mr. Christian Carrier, the Director of the Nuclear Laboratories and Research Reactor Division, Mr. Don Howard, the Director of the Waste and Decommissioning Division, Ms. Kim Campbell, who led the production of the annual performance report. Also with us today are licensing and compliance staff, as well as subject matter experts to help answer any questions that the Commission may have. We are here today to present Commission Member Document CMD 14M79 entitled Annual Performance Report for AECL's Nuclear Sites and Projects 2013. Before starting the presentation, I would like to note that while the report was being written, AECL completed a very significant milestone in its restructuring and is now referred to as Canadian Nuclear Laboratories Limited. We will continue to refer to Canadian Nuclear Laboratories, or CNL, for the duration of this presentation. That being said, we will probably, from time to time, accidentally lapse and use AECL, but you'll know what we mean. Okay. Why are we on 8?
Technical difficulties.
I'll keep talking while the slides catch up. Table of contents, this slide's the areas that will be covered in today's presentation. Slide 3, I will now provide a brief introduction. The CNSC regulates Canada's nuclear facilities to protect the health, safety, and security of Canadians and the environment. The CNSC achieves this mandate through licensing, reporting, compliance verification, and, when necessary, enforcement. Slide 4. Safety performance is continually determined by staff using a risk-informed approach. That is, the compliance program is developed and planned commensurate with the risk associated with the facility, the complexity of the facility, and past performance of how well the licensee has managed its licensed facilities and activities associated with the risks. CNSC staff also verify compliance through monitoring and desktop reviews of annual and quarterly compliance reports. The compliance program is supplemented with meetings with licensees to ensure clarity of CNSC's expectations. Finally, safety...
Sorry to interrupt. Are you going to put the slide deck on or not? Can you... Okay.
So, just
go ahead.
On slide 4, to complete. Finally, safety performance is also determined by inspection using qualified inspectors supported by specialist subject matter experts. 5. CNSC staff assess the safety performance of licensees using a rating methodology that was established in 2010 and is based on multiple sources of input covering 14 safety and control areas. The 14 SCAs are illustrated on the right-hand side of this slide. The inputs for the assessment include findings taken from inspections, follow-ups, and desktop reviews. These findings come from the assessments conducted by CNSC staff at a topical area level within each of the safety and control areas. In the past, the CNSC has produced a report on the performance of CNL's Chalk River Laboratories. This year, the scope of the report has been expanded to include an assessment of CNL's major nuclear sites and projects. The report, entitled Annual Performance Report, AECL's Nuclear Sites and Projects 2013, summarizes CNSC's staff assessment of the safety performance of all CNL sites and projects where physical operations occurred in 2013. These sites and projects include Chalk River Laboratories, Whiteshell Laboratories, Port Hope Area Initiative, which includes the Port Hope project and the Port Granby project. It should be noted that this is the first performance report for CNL's nuclear sites and projects, and in turn will be the last report for AECL. The report highlights the regulatory requirements and expectations in selected areas and discusses significant events, license changes, major developments, and overall performance. It provides performance data on all of the 14 of the safety and control areas where applicable. The report focuses on the year 2013, but also provides updates on key issues up to June 30th, 2014. I will now provide a brief overview. Next. CNSC inspectors are stationed in Ottawa at CNSC headquarters and are stationed at the Chalk River Laboratory site. As you can see from this table, in 2013, CNSC inspectors conducted 28 site compliance inspections, 22 at Chalk River Laboratories, 3 at Whiteshell, 3 for the Port Hope Area Initiative. In addition to the inspections conducted, CNSC staff also performed desktop reviews to verify CNL's compliance with the regulatory requirements. A total of 109 desktop reviews were completed by staff in 2013. Note that the number of inspections and desktop reviews vary from site to site and reflect the risk-informed nature of staff's compliance verification program. To keep communication lines open with CNL, CNSC staff also hold monthly and quarterly meetings with CNL to discuss the performance of various safety and control areas. The table on this slide shows the performance ratings for Chalk River Laboratories, Whiteshell, the Port Hope project, and the Port Granby project. You will note that for all sites, most safety and control areas are satisfactory, SA. For the 2 projects under the Port Hope Area Initiative, there are 3 safety and control areas rated as not applicable, NA. One notable exception is the below expectations shown as BE rating for the fitness for service safety and control area for Chalk River Laboratories. The ratings presented in this table will be discussed in more detail within the site or project specific sections of today's presentation. In terms of overall performance, CNSC staff compliance activities during 2013 have confirmed that no member of the public received a radiation dose that exceeded the regulatory limit. No worker at CNL site received a radiation dose that exceeded the regulatory limits. The frequency and severity of non-radiological injuries to workers was minimal. No radiological releases to the environment from the sites and projects exceeded the license limits. And finally, CNL complied with its license obligations concerning Canada's international obligations. I will now speak briefly to AECL's restructuring. On February the 28th, 2013, the Minister of Natural Resources announced that Canada would undertake competitive procurement for a contractor to manage the operations of AECL's nuclear laboratories using a government-owned contractor-operated, otherwise known as GOCO model. As part of the procurement process, Canadian Nuclear Laboratories was created in May 2014 as a wholly owned subsidiary of AECL. The licenses were transferred from AECL to CNL, and on November the 3rd of this year, CNL was fully operationalized. In late 2015, the procurement process will conclude and a private contractor will take ownership of CNL. I note further that CNL, AECL, NRCan, and CNSC staff are due to come back to the Commission to give an update on the procurement and restructuring, and that will occur in February 2015. Turning to the Nuclear Legacy Liabilities Program, NLLP, was established by the Government of Canada in 2006 to manage Canada's nuclear legacy liabilities at CNL sites. The main objective of the NLLP is to safely and cost-effectively reduce the nuclear legacy liabilities on CNL sites and the associated risks based on sound waste management and environmental principles. The nuclear legacy liabilities are associated with a number of CNL sites, as can be seen on this slide. Currently, Douglas Point, NPD, and Gentil 1 are each in a safe storage state with no operational activities taking place during 2013, and therefore were not included in this year's report. This may change in next year's report if decommissioning activities begin. The Port Hope Area Initiative, shown in blue for completeness, but is noted that it is funded outside of the NLLP. Chalk River and Whiteshell contain the majority of the nuclear legacy liabilities. At these sites, the inventory of legacy wastes includes used nuclear fuel and intermediate level and low level solid and liquid radioactive waste, as well as contaminated lands, buildings, structures, and tanks. In January 2014, a series of meetings were held to discuss strategic initiatives associated with the NLLP activities. The objective of the meetings was to ensure a better informed approach and alignment with international best practices in the development of waste solutions, executing selected projects, and developing an acceptable disposal strategy, all to be considered in the context of the NLLP. The NLLP projects and associated actions and milestones are also subject to the CNSC compliance activity. CNL submits semi-annual progress updates on key NLLP projects and matters of interest. As previously mentioned, the Port Hope Area Initiative is funded separately from the Legacy Program. The Port Hope Area Initiative is defined by a legal agreement between the Government of Canada and the municipalities of Port Hope and Clarington for the management of the historic low-level radioactive waste within each of the respective communities. The agreement came into effect in March 2001. In a news release from January 13, 2012, Canada's Minister of Natural Resources announced that the Government of Canada is investing $1.28 billion over 10 years to clean up low-level radioactive waste in the Port Hope area. More information on the Port Hope Area Initiative and the performance of its projects will be presented later in the presentation. Since 2011, CNL has made significant progress in developing its corporate public information program and disclosure protocol and incorporating its activities among its various sites which meet the requirements of RDGD 99.3 public information and disclosure. Key components of CNL's overall program include the CNL Contact newsletter, CNL's own website, and continued Aboriginal engagement. There are also site-specific components to this program. These include the CRL Environmental Stewardship Council, the Whiteshell Public Liaison Committee, the Port Hope Area Initiative Public Information Exchange, and finally the Port Hope, Port Granby Citizen Liaison Groups. Addressing the lessons learned from the nuclear accident at the Fukushima Daiichi nuclear power plant in Japan continues to be a focused area for CNSC staff in 2013 for both the Chalk River and the Whiteshell sites. CNL has reviewed its existing safety cases and emergency management programs against the ability to withstand extreme external events. By reviewing CNL's reports, CNSC staff concur that the underlying defense in-depth provisions are in place to deal with such natural disasters. CNSC staff continue to track the open Fukushima actions as they move towards closure. Both CRL and Whiteshell have remaining open actions, as can be seen on this slide. I will now pass the presentation to Mr. Christian Carrier to present CNSC's staff assessment of the performance of CNL's Chalk River Laboratories. Thank you.
Good morning, Mr. President. My name is Christian Carrier. I'm the Director of the Nuclear Laboratories and Research Reactor Division. So, next slide, please. As depicted on this slide, the Chalk River Laboratories, or CRL, are located on the south shore of the Ottawa River in the province of Ontario, 160 kilometers northwest of Canada's national capital, Ottawa. CRL is one of the most complex nuclear facilities in Canada. The CRL site is occupied by more than 150 buildings. Outside of the build-up area, there are several waste management areas for handling and storage of both nuclear and non-nuclear waste. CNL employs approximately 3,000 people at the CRL site. The CRL site provides for the production of medical isotope, the delivery of various nuclear services, and the conduct of a variety of research and development programs. The CRL site license was renewed in 2011. To support license renewal and the continued operation of the NRU reactor, CNL implemented the NRU Integrated Implementation Plan, otherwise referred as the IIP. CNSC staff have and will continue to monitor the effective implementation of this improvement initiative. As seen from this table, all performance rating for CRL ranged from below expectations to satisfactory for the reporting period. A notable rating change was issued for the SCA management system, previously reported as below expectation in the 2012 annual report. CNL has completed several improvements, including the transition to the CSA standard N286 version 2005, which have resulted in the satisfactory rating. Regarding the SCA fitness for service, CNSC staff continue to rate this SCA as below expectations due to the aging and legacy issues of structure systems and components at CRL, particularly the NRU reactor. The next two slides will provide more details on those two safety and control areas and their performance. For the review period, CNSC staff rate the management system SCA at CRL as satisfactory. This is primarily based on the progress related to AECL's transition to the CSA standard N286 version 2005, the improvements made in safety culture, and the further implementation of the Operating Experience Program. Safety culture at CRL has been the object of important strides for improvements, especially since the 2009 vessel leak event. In response to this event, CNL undertook significant effort to improve a wide range of programs of elements of safety culture and human performance. Cnsc staff have noted noticeable improvements to safety culture at CRL through their compliance activities. For fitness for service, Cnsc staff continue to rate this SCA as below expectations. This is primarily due to the aging and legacy issues of system structures and components, especially the NRU reactor. Even though CNL continue to experience challenges due to equipment aging in all instances, CNL has taken actions to mitigate or correct deficiencies. Strategic programmatic improvements, as listed on this slide, are being implemented to increase the performance rating in this SCA. CNSC staff notes an improving trend in this SCA. CNSC staff will continue to monitor the progress of this SCA. For the review period, CNSC staff continue to rate the radiation protection SCA at CRL as satisfactory. CNL has implemented and maintained a radiation protection program to control the radiological hazard present in its facilities and to ascertain doses for each person who performs duties in connection with their licensed activities. No worker at the CRL site was exposed to a dose that exceeded regulatory limits. The dose data presented in this figure is taken from CNL's annual safety reports for the years 2011 through the year 2013. Please note that this figure uses a logarithmic scale. The average effective dose to workers at CRL during the period is low. It was approximately 0.4 millisieverts per year, or 0.8% of the annual regulatory dose limit of 50 millisieverts. The maximum annual individual whole-body dose for nuclear energy workers at CRL site was 8.89 millisievert in 2013. The majority of the doses received by workers came from the operational activities within the NRU reactor and for the production of molybdenum-99. The dose to the public from CRL is calculated by using environmental monitoring results. Airborne and liquid exposure pathways, such as inhalation and ingestion, are taken into account when determining public doses. The table displayed here compares public doses for the year 2011 and 2013. As you can see, doses to the public continue to be well below the regulatory annual public dose limit of 1 millisievert. As shown in this slide, there were 18 recordable lost time incidents in 2013 at CRL. The severity rate of lost time incidents in 2013 are reduced below levels in the previous years. The reduction in severity rate is a direct result of increased management focus on the Return to Work program. This program supports the safe and early return to work within the abilities of the injured worker, leading to fewer lost work days. In 2013, CNL provided more training to its employees, increasing awareness of occupational hazards, and put further measures in place to reduce the exposure to conventional hazards. This included, for instance, improved machine guarding, protective equipment and clothing, and the introduction of a safe lifting, hoisting, and ridging procedure. For the review period, CNSC staff continue to rate the conventional health and safety SCA at CRL as satisfactory. Overall, compliance verification activities conducted at CRL facilities confirmed that CNL continues to view conventional health and safety as a paramount consideration. CNL has demonstrated a satisfactory ability to keep its workers safe from occupational injuries. CNSC staff meet quarterly with CNL to discuss the performance of this SCA. For the safety area environmental protection, CNL continues to implement and maintain an adequate environmental protection program. This program controls and monitors releases of radioactive and hazardous substances and their effects on the environment. In 2013, there were no airborne or liquid exceedances of the effluent release limits. From its review, CNSC staff have assessed the safety area as satisfactory. Like other programs, CNSC staff holds quarterly meetings with CNL to discuss the performance of this SCA. Airborne radiological emissions remain effectively controlled. The main contributor to public dose from the site is argon-41, resulting from the operation of the NRU reactor and the production of medical isotopes. In 2013, there were 30 action level exceedances for airborne releases. It should be emphasized that the setting of these action levels is a small fraction of the regulatory or license limits. As such, these exceedances were a small contribution to the total releases from the corresponding monitoring period. The next slide will provide more detail on these exceedances. CNL sets the action levels at CRL slightly above values normally encountered during normal operation to immediately identify abnormal conditions. As can be seen from the graph displayed, there were many action level exceedances in the late summer and fall of 2013. These exceedances were the subject of a common investigation by AECL and was the subject of a significant monitoring by CNSC staff. Again, incremental releases were negligible when compared to normal operational releases from the site. Those normally average between 5 and 6 microsieverts per month. And this is doses to members of the public. CNL determined that the cause of those exceedances was the processing of higher than usual irradiated targets for the production of Moly-99. Additional causal factors were identified as a reduction in the frequency of nuclear ventilation filters in the Moly-99 facility and the contamination of the molybdenum-99 waste flask. CNL has implemented corrective measures that were effective in preventing recurrence. CNSC staff conclude that the setting of these action levels were effective in the early detection of potential problems at site and has allowed CNL to investigate and take prompt corrective actions. Liquid radiological emissions are effectively controlled at CRL. In 2013, the annual average tritium concentration in drinking water at the town of Petawawa and the city of Pembroke was 2.5 becquerel per liter. This is well below all national and international limits for tritium in drinking water. Also, in 2013, there were no action level exceedances for liquid releases at CRL, including radioactive and non-radioactive releases. Subsequent to the Fukushima accident, CNL was requested to review initial lessons learned from the event for the CRL site and to reassess the safety cases for its facilities. CNSC staff conclude that the underlying defense in depth provisions are in place to deal with natural disaster and accident at the CRL. In addition to the reassessment of the safety cases, CNL developed an action plan to address the lessons learned from the Fukushima Daiichi accident, which include short, medium, and long-term actions. This action plan has been incorporated into the IIP, which is a condition of the license. CNL has completed the development of a severe accident management guidelines and are on track with full implementation in NRU for the year 2015. CNSC staff will continue to monitor progress of these actions to ensure lessons learned from the Fukushima accident are implemented at the CRL. In April 2010, the Government of Canada and the United States committed to work cooperatively to repatriate spent highly enriched uranium fuel currently stored at the Chalk River Laboratories. In 2012, this effort was expanded to the return of additional inventories of HEU material, including those in liquid form. All shipments of HEU will follow stringent transportation and security requirements. In 2013, CNL repatriated 2 disassembled HEU slowpoke research reactor fuel cores to the U.S. These included cores from the École Polytechnique and the Canada reactor slowpokes. This slide provides an update on the transportation package certification and the detail for HEU. The transport package for the repatriation of spent fuel rods from CRL research reactors has been certified in both the Canada and in the U.S. The certification process for HEU in liquid form includes independent reviews by the U.S. Regulatory Commission, the U.S. Department of Transportation, and the CNSC. The certification process is still ongoing in both countries. CNSC staff technical assessment of the design of the package is nearing completion. CNSC staff plans to post this technical assessment document on its public website for a period of public comments. This is likely to be done before the end of the calendar year. CNSC's focus for the year 2014-2015 for Chalk River is summarized on this slide. As required under a license condition, CNL will submit a plan before the end of June 2015 for the end of operation or the continued operation of the NRU reactor beyond October 31st, 2016. As a result, the IIP will require an amendment to address the specific decision on this matter. CNSC staff will review this plan and continue monitoring implementation of the IIP. The government's decision to cease Moly-99 production will effectively result in cessation of the operation of a molybdenum-99 production facility. This is after October 31st, 2016. Regulatory focus will be on the orderly shutdown process of this facility and definition of a safe shutdown with surveillance state. Finally, in preparation for the GOCO implementation for the management of the CNL, CNSC staff will ensure that rigorous processes are in place to manage changes at site, in particular, changes that involve change to the organization. This concludes my presentation of the Chalk River Laboratories. I will now pass the presentation over to Mr. Don Howard.
Thank you and good morning. For the record, my name is Don Howard and I am the Director of the Waste and Decommissioning Division. This section of the presentation will summarize CNL's performance associated with the Whiteshell Laboratories. CNL continues to operate the Whiteshell Laboratories in compliance with the Nuclear Safety and Control Act and its associated regulations and its license. CNSC staff will continue to conduct compliance activities on an ongoing basis to verify CNL's continued safe operation of Whiteshell according to the authorizations and conditions of its license. As shown on this slide, the Whiteshell Laboratories is located 100 kilometers northeast of Winnipeg, Manitoba, and operated from 1961 to 1997. This is where CNL pioneered the development of dry storage containment. The site is currently under decommissioning. The Whiteshell site encompasses an area of 4,375 hectares. The site comprises of a number of nuclear and non-nuclear facilities and activities, including the White Shell Reactor, WR1, the shielded facilities, the liquid and solid radioactive waste management facilities, and various research laboratories. CNL currently possesses a decommissioning license for White Shell expiring on December 31st, 2018. As shown on this slide, performance ratings for White Shell for the year 2013 were all satisfactory or fully satisfactory. These ratings remain unchanged from reports previously made to the Commission. For the review period, CNSC staff continue to rate the Radiation Protection SCA as satisfactory. CNL has implemented and maintains a radiation protection program to control radiological hazards, ascertain doses to workers, and estimate doses to the public. CNL continues to strive to maintain doses to workers ALARA by executing radiological work in the 2011 to 2013 period with minimal dose consequence, no internal intakes, and no significant contamination or exposure events. During the review period, no worker at the White Shell site received a dose that exceeded the regulatory limits. The dose data presented in this figure is taken from the CNL's annual safety reports for the years 2011 through 2013. The average effective dose to workers at White Shell during the period is low. It was approximately 0.03 millisieverts per year, or 0.06% of the annual regulatory dose limit of 50 millisieverts. The maximum annual individual whole body dose for nuclear energy workers at the White Shell site was 0.8 millisieverts in 2013. The dose to the public from White Shell is calculated by using environmental monitoring results. Airborne and liquid exposure pathways, such as inhalation and ingestion, are also taken into account when determining public dose. The table on this slide compares public doses for the years 2011 to 2013. As you can see, doses to the public continue to be well below the regulatory annual public dose limit of 1 millisievert. A key performance measure for conventional health and safety SCA is the number of recordable lost time injuries that occur per year. As you can see from the table, for 2013, the number of lost time incidences and their frequency is relatively stable. However, the severity rate is increasing. This means a considerable number of injuries at White Shell are resulting in extended absences from the workplace. Although most of these injuries are minor, improvements to the return to work program are still required to minimize the number of days lost. CNL is currently in the process of implementing these improvement actions. For the review period, CNSC staff continued to rate the conventional health and safety SCA at White Shell as satisfactory, as CNL continues to view conventional health and safety as a paramount consideration in all decommissioning activities. CNL continues to implement and maintain a comprehensive industrial health and safety program for the White Shell site. CNL has improved aspects of the program based on best industry practices and results from accident investigations and internal audits. CNSC staff will continue to monitor performance of this SCA. For the review period, CNSC staff rate the environmental protection SCA at White Shell as satisfactory. CNL continues to implement and maintain an environmental protection program to control and monitor liquid and air releases of radioactive and hazardous substances to the environment. In 2013, there were no airborne or liquid exceedances of the effluent release limits or action levels at White Shell. In 2013, both airborne and liquid radiological emissions were effectively controlled. The maximum airborne emissions were less than 0.0005% of the derived release limits, or DRLs. For liquid, the annual average tritium concentration in drinking water in the Winnipeg River was between 2.5 and 3.5 becquerels per liter. This is well below all national and international limits for tritium in drinking water. CNSC's regulatory focus for 2014-15 for whiteshell is summarized on this slide. This includes an update to the Whiteshell Laboratories decommissioning license to include standard license conditions and the license conditions handbook. Also, acceleration of the overall whiteshell decommissioning schedule. I will now switch the focus of the presentation to the Port Hope Area Initiative. The Port Hope Area Initiative comprises two distinct community-based projects, the Port Hope Project and the Port Granby Project. This slide provides a summary of CNL's implementation of public information program and disclosure requirements. CNL is currently implementing its Port Hope Area Communication Plan and is committed to disclosing information about the projects with stakeholders in a timely, accurate, and comprehensive manner. These activities include mailing out newsletters to the public, posting recent project news and updates to the website, porthopeareainitiative.ca, launching citizen liaison groups for both the Port Hope Project and the Port Granby Project. CNL also maintains the Port Hope Area Initiative Project Information Exchange, where members of the public are welcome to drop in, meet with staff, and learn more about the two projects. In 2013, CNL conducted public information activities for the Port Hope Area Initiative that met CNSC regulatory requirements. Ratings for the Port Hope Project and the Port Granby Project for the year 2013 are presented on this slide. CNL was rated satisfactory for all SCA ratings during the reporting period. These ratings remain unchanged since performance reporting at the onset of each license. CNL has implemented the Port Hope Area Initiative Radioactive Material Transportation Plan to govern transport of radioactive material. The plan meets regulatory requirements. Once remedial activities begin, waste material will be transported to the long-term waste management facility via the prescribed transport routes. During the review period, no radioactive material was transported. CNSC's regulatory focus for 2014-2015 is summarized on this slide. CNL has commenced resurveys of properties in the municipality of Port Hope and has commenced plans for cleanup activities. CNSC staff plan to conduct compliance verification activities during this period to verify that these activities are conducted in a safe and effective manner. Construction of the wastewater treatment plants is completed and commissioning is underway and will continue into 2015. CNSC staff will conduct on-site inspections and reviews of performance data to ensure that design objectives have been met. Wastewater treatment plant commissioning performance data will be used to establish new effluent limits for each site. The following 8 slides summarize CNL's 2013 Safety and Control Area performance ratings associated with the Port Hope Project and provides an update of activities presently underway. These slides indicate that CNL continues to operate the Welcome Waste Management Facility and plan for construction and remedial activities in compliance with the Nuclear Safety and Control Act and its associated regulations and its license. CNSC staff will continue to conduct compliance activities on an ongoing basis to verify CNL's continued safe operation of the Welcome Waste Management Facility. The slides for the Port Hope and the Port Granby projects are very similar, but the Port Granby activities are further along, so the info will differ as the projects move forward. The Port Hope project activities include the construction and operation of a new long-term, low-level radioactive waste management facility, remediation of the existing Welcome Waste Management Facility, and remediation of sites containing historic low-level radioactive waste located within the municipality of Port Hope. As noted on this slide, project activities are being conducted by CNL in 3 phases. Phase 2 is underway and includes ongoing care and maintenance of the Welcome Waste Management Facility, off-site activities, and the construction of a new long-term waste management facility. As part of the Phase 2 activities, CNL has constructed a new wastewater treatment plant adjacent to the existing water treatment facility and is currently undergoing commissioning. With respect to the construction of the new long-term waste management facility and the remediation of the existing Welcome Waste Management Facility, CNL has begun construction of on-site infrastructure and support facilities, the excavation and temporary on-site stockpiling of soils, and preparation for the construction of the long-term waste management facility containment mound. As was noted earlier, CNL has commenced resurveys of properties in the municipality of Port Hope. As noted earlier, all safety and control areas have been rated satisfactory for the Port Hope project. Next slide. This slide represents the worker effective dose for 2012-2013. It should be noted that currently CNL does not monitor doses separately between the workers for the Port Hope and the Port Granby projects. Therefore, for both projects, the average effective dose to workers during the review period is low. It was approximately 0.01 millisieverts per year, or 0.02% of the annual regulatory dose limit of 50 millisieverts. The maximum annual individual whole body dose for a nuclear energy worker was 0.2 millisieverts in 2013. CNL estimates doses to the public by using environmental TLDs posted on the perimeter fence of the Welcome Waste Management Facility. Monitoring results for the review period indicate that doses to the public are an order of magnitude below the regulatory limit of 1 millisievert per year. For the review period, CNSC staff continue to rate the radiation protection SCA as satisfactory. CNL has implemented and maintains a radiation protection program to control radiological hazards, ascertain doses to workers, and estimate doses to the public. During the review period, no worker at the Port Hope project site resulted in a dose that exceeded the regulatory limits. CNSC staff rate the environmental protection SCA at the Port Hope project as satisfactory. Oversight is a joint effort which is accomplished by the establishment of a joint regulatory group. The role of the joint regulatory group is to provide for a harmonized regulatory approach for the Port Hope Area Initiative. Other members of the joint regulatory group include, for example, Environment Canada and the Ontario Ministry of the Environment and Climate Change. CNSC staff rated the conventional health and safety SCA as satisfactory, as CNL continues to maintain an acceptable conventional health and safety program and has had no lost time injuries at the Port Hope project during the review period. Now the following slides will summarize the 2013 SCA performance ratings and provide an update of the Port Granby project activities. These slides indicate that CNL continues to operate the Port Granby Waste Management Facility and plan for construction or remedial activities in a manner compliant with the NSCA and its associated regulations and its license. CNSC staff continue to conduct compliance activities on an ongoing basis to verify CNL's compliance with authorizations and conditions of its license. The Port Granby project activities include the construction and operation of a new waste management facility and remediation of the existing Port Granby waste management facility. As noted on this slide, project activities are being conducted by CNL in 3 phases. Phase 2 is underway and includes ongoing care and maintenance of the Port Granby waste management facility, in addition to the construction of a new long-term waste management facility. As part of the Phase 2 activities, CNL has constructed a new wastewater treatment plant to the north of the existing water treatment facility. The tendering process for the remediation of the existing facility and the construction of the new long-term waste management facility is currently underway. As noted earlier, all safety and control areas have been rated satisfactory for the Port Granby project. As previously shown on an earlier slide, the average effective dose to workers at the Port Granby project is low, 0.01 millisievert, with the maximum effective dose of 0.2 millisievert per year, or 0.02% of the annual regulatory dose limit of 50 millisieverts. CNL estimates doses to the public by using environmental TLDs, which are posted on the perimeter fence. Monitoring results for the review period indicate an estimated dose to the public well below the regulatory limit of 1 millisievert. For the review period, CNSC staff continued to rate the radiation protection SCA as satisfactory. CNL has implemented and maintains a radiation protection program to control radiological hazards, ascertain doses to workers, and estimate doses to the public. During the review period, no worker at the Port Granby project site resulted in a dose that exceeded the regulatory limit. CNL has implemented and maintains an environmental protection program to monitor and control releases to the environment. As noted earlier, the CNSC staff established a joint regulatory group for the Port Hope Area Initiative. CNSC staff rated conventional health and safety SCA as satisfactory, as CNL continues to maintain an acceptable health and safety program and has had no lost time injuries at the Port Granby project during the review period. This concludes this portion of the presentation, and I will now pass it back to Mr. Newland.
Thank you, Dom. I will now present CNSC staff's closing remarks. Evaluations conducted by CNSC staff during the review period confirm that CNL has operated the nuclear sites and projects safely. These assessments confirm that no member of the public received a radiation dose that exceeded the regulatory limit. No worker received a radiation dose that exceeded the regulatory limits. The frequency and severity of injuries and accidents involving CNL workers was minimal. There were no radiological releases that exceeded the regulatory limits. And finally, CNL has complied with the Nuclear Safety and Control Act, the regulations, and their license conditions. This concludes CNSC staff's presentation of the annual performance report for CNL's Nuclear Sites and Projects 2013, and we are now prepared to answer any questions that the Commission may have. Thank you.
Thank you.